SpaceX, founded by Elon Musk in 2002, is transforming the aerospace industry with its focus on reusable rockets. Unlike traditional rockets, which are discarded after a single use, SpaceX's rockets, such as the Falcon 9 and Falcon Heavy, are designed to return to Earth, land safely, and be reused for future missions. This shift in strategy is rooted in solving the challenges of cost, waste, and inefficiency that have long plagued space travel, while opening new possibilities for humanity's future in space. Historically, rockets have been treated as disposable vehicles, discarded after every flight. This approach is not only wasteful but also prohibitively expensive, as each launch requires a newly built rocket. The result has been limited access to space, with costs for a single launch running into hundreds of millions of dollars. This inefficiency made spaceflight viable only for large governments and organizations such as NASA and the European Space Agency. Additionally, the disposal of rockets creates debris and environmental waste, making this model unsustainable over time. SpaceX saw an opportunity to disrupt this system by pursuing reusability, recovering rockets, refurbishing them, and flying them again. The economic advantages of reusability are a driving force behind SpaceX's efforts. A typical Falcon 9 launch costs around $67 million, but building the rocket's first stage accounts for nearly 70% of that price. Reusing the first stage across multiple flights significantly lowers the cost of each mission, making it affordable for smaller companies and nations to send payloads into space. With this model, launches that once cost over $300 million can now be conducted at a fraction of the price. This reduction in costs has fueled the growth of the commercial satellite industry and enables frequent, affordable missions.
If you look at, say, the cost of a Falcon 9 rocket, which is quite a big rocket, it's about 1 million pounds of thrust, and it is the lowest cost rocket in the world, but even so, it's about $50 to $60 million. But the cost of the fuel and oxygen and so forth is only about $200,000. So obviously, if we can reuse the rocket, say 1,000 times, then that would make the capital cost of the rocket per launch only about $50,000. There'd be maintenance and other things that would factor in there, and fixed costs and some overhead allocation and whatnot. But it would allow for about a 100-fold reduction in launch costs. And this is a pretty obvious thing if you think about it as applied to any other mode of transport. You can imagine that if planes were not reusable, very few people would fly. 747 is about $300 million. You'd need 2 of them for a round trip. And yet I don't think anyone here has paid $500 million to fly. And the reason is because those planes can be used tens of thousands of times, and so all you're really paying for is fuel and pilot costs and just sort of incidentals, and the capital cost is relatively small. So the pivotal breakthrough that's necessary, that some company has to come up with to make life multiplanetary, is a fully and rapidly reusable orbit-class rocket. This is a very difficult thing to do because we live on a planet where that is just barely possible. If gravity were a little lower, it would be easy. If it was a little higher, it would be impossible. Even for an expendable launch vehicle, where you don't attempt any recovery, after a lot of smart people have done their best to optimize the weight of the vehicle and the efficiency of the engines and the guidance system, everything, you get maybe 2 to 3% of your liftoff weight to orbit. That's not a lot of room for error. So if your rocket ends up being just a little bit heavier, you get nothing to orbit. And this is why only a few countries have ever reached orbit. Now you say, okay, well, let's make it reusable, which means you've got to strengthen the stages, you've got to add a lot of weight, a lot of thermal protection, you've got to do a lot of things that add weight to that vehicle and still have a useful payload to orbit. This is Now you're saying of that meager 2 to 3%, and maybe if you're really good, get it to 4. You've got to add all that's necessary to bring the rocket stages back to the launch pad and be able to refly them and still have useful payload to orbit. So a very difficult thing. This has been attempted many times in the past, and generally what's happened is when people have concluded that success was not one of the possible outcomes, then the project's been abandoned. Now, we could fail. I'm not saying we're certain of success here, but we're going to try to do it.
Another key benefit of reusable rockets is the potential for rapid turnaround. Traditional rockets require months of preparation between launches, but SpaceX envisions a future where rockets can be reused within 24 hours, similar to how airplanes operate. Rapid reuse will allow for more frequent and flexible missions, increasing efficiency and reducing downtime. This capability is essential as SpaceX takes on a growing number of clients, from commercial satellite companies to government agencies and even private space tourism ventures. The environmental impact of reusable rockets is another significant factor. By recovering and reusing rockets, instead of allowing them to burn up in the atmosphere or sink in the ocean, SpaceX reduces both waste and pollution. Additionally, emissions are spread across multiple flights, lowering the environmental footprint of each individual launch. Although rockets like Falcon 9 still use kerosene-based RP-1 fuel, the environmental impact is mitigated through reuse and sustainable engineering practices. Beyond economics and the environment, reusability is essential for SpaceX's long-term vision of interplanetary travel. Elon Musk's ultimate goal is to make humanity a multiplanetary species by establishing a permanent settlement on Mars. Sending people and supplies to Mars will require thousands of missions, a goal that is only achievable with reusable rockets. SpaceX is also developing technology to refuel rockets on Mars using locally sourced methane and oxygen, enabling rockets to return to Earth and ensuring two-way travel. Without reusable systems, colonization would be economically and logistically impossible. SpaceX's reusability efforts are also creating new opportunities for industries such as space tourism. Lower launch costs mean that non-astronauts may soon have the chance to travel to space. The Starship rocket, currently under development, is designed to carry tourists around the Moon, with eventual plans for flights to Mars. In addition, reusable rockets are driving growth in the satellite industry, with constellations like Starlink offering global internet coverage thanks to frequent, affordable launches. Achieving reusability has required significant technological innovation. SpaceX developed precision-guided landing systems that allow rockets to return to Earth and land vertically, even on floating drone ships in the ocean. The company has also created heat shields and landing legs that protect rockets during the intense re-entry process. For its next-generation Starship rocket, SpaceX has engineered advanced Raptor engines, which run on methane and are specifically designed for deep space missions. SpaceX's focus on reusable rockets has disrupted the aerospace industry, forcing competitors such as Blue Origin and United Launch Alliance to develop their own reusable systems to remain competitive. This disruption has ushered in a new era of space exploration, making missions more affordable and frequent. Government agencies now have more launch options for scientific research, national defense, and space exploration, accelerating global progress. Interestingly, reusing rockets improves their reliability over time. With each flight, engineers collect data on how the rocket performs, allowing them to address potential issues and enhance safety. For example, some Falcon 9 boosters have been flown over 16 times, proving that a well-maintained rocket can complete numerous missions without compromising performance. Each flight also provides insights that improve rocket design, making future missions safer and more efficient. SpaceX's pursuit of reusable rockets marks the beginning of a new chapter in spaceflight. By lowering costs, improving efficiency, and reducing environmental impact, SpaceX is making space more accessible than ever before. Reusable rockets are not only revolutionizing how we explore space today, but are also laying the foundation for interplanetary missions and the colonization of Mars. What was once a rare and expensive endeavor is becoming a routine and scalable operation, transforming humanity's relationship with the cosmos and setting a new standard for the future of space exploration.
We're going to land 13 engines, burn off all of that velocity. Oh, we can see it coming down through the plume.
Booster coming in hot for booster catch.
We're going to ignite 13 of those Raptor engines, and this view is incredible right now. You can see how fast this vehicle is moving on the left-hand side.
Landing burn has been ignited. We're now down to 3 Raptor engines. We can see those chopsticks now in view.
Megabilla has caught the booster.
This is absolutely insane. On the first ever attempt, we have successfully caught the Super Heavy booster back at the launch tower.
What an incredible view!
Are you kidding me?
Dan,
Wow.
I don't know about you, but we're losing our stuff up here.
Guys, I'm sorry. Like, even in this day and age, what we just saw, that looked like magic. Wow.
Dan, your view must have been insane. We are still going wild over here over this.
Folks, this is a day for the engineering history books. This is a live view of the Super Heavy booster as it has just been successfully caught back at the very same launch tower that it just came from. Dan, I love this. You are reflecting exactly what everybody else here in Hawthorne, except maybe a little bit more because you got to see it with your own eyes.
How was that?
We got it. I mean, I can't even describe that. Oh, by the way, main engine cut off, ship's in orbit, but I am like shaking right now. That was.
Yeah, this is not,
Yeah,
I mean,
let's check in on ship.
It's hard to believe that.
Starship nominal orbit insertion.
All right, exciting news there. It's hard to believe that, booster isn't the only excitement that we have today. Just confirmation there. A gorgeous view of planet Earth behind the ship.
Saved.
And it is now in the orbit that we expected it to. This is just an incredible day. Live views there as the booster vents some pressures there. That is a live view from the top of the tower looking at the chopsticks.
I am still in disbelief. I'm trying to catch my tears just like the chopsticks caught the booster. It has been nonstop since liftoff. And we are all so excited about everything that's been happening so far this morning. With the booster having completed its job for today, we are going to take a short break for the next 30 minutes. We'll return back at T plus 40 minutes while the ship continues to coast before re-entry.